This lecture is on scientific notation, which is actually a way to write a number, and how the form looks like is it has to look like a times 10 to the power of n, and the requirement is that the numerical value of a has to be between 1 and 10. So let's talk about going from standard notation to scientific. So if we give you the number in standard notation, how do you write it in scientific notation? The rule is this. Step 1, you're supposed to move the decimal point to the right of the first non-zero digit. Okay, that's the first thing. Then depending on the movement, if decimal point is moved n places to the left, then you multiply by 10 to the power of n. If moved to the right, then multiply by 10 to the power of negative n. Okay, so let's see if you understand this. So assuming this is standard notation and I wish to convert to scientific notation. Okay, so let's try the first number. Supposedly you are given 68,000. So you're supposed to move the decimal point to the right of the first non-zero digit. So the very first non-zero digit is 6, and you're supposed to move the decimal point up to there. So right now, 68,000 means the decimal point is way at the back, because it's a whole number. So from all the way in the back, how do you move all the way up there? So that tells you that you have to move 1, 2, 3, 4 places to the left. So that makes the number 6.8 times, because it's to the left, you have to use 10 to the power of 4. Okay, let's try, for example, 0.003507. So you need to move the decimal point to the very first non-zero digit and the right of it. That means right here. That's the very first non-zero digit. So that's 3. And you have to move to right behind 3. Okay, so from where you are right now, the decimal point, you have to move 1, 2, 3 places to the right. Now because it's to the right, you now use a negative exponent. So this will read 3.507, but times 10 to the power of negative 3. Okay, now this applies even to negative numbers. For example, negative 783, for example. Okay, so you're supposed to move to the very first non-zero digit, that's this one right here, and you need to go to the right of it. So right now your decimal is right behind the 3 because it's a whole number. And you notice you have to move 2 places to the left, and because it's a left, it's a positive exponent, except now your decimal is negative 7.83, but that will be 10 to the power of 2. Okay, so observe the form is you have to look like a to the power of n so long as the numerical value of a is between 1 and 10, which is right here. Let's try the reverse. Supposedly you want to go from scientific notation and you wish to convert back to standard notation. Okay, so supposedly this was 3.52 times 10 to the power of 3. So let's make sure you understand. Really, this means 3.52 times 1,000. 1,000 because 10 to the power 3 is 1,000. And when you multiply something by 1,000, it's equivalent to moving the decimal point to the right, and you move it 3 decimal places. So it's 1, 2, 3. But because there's a gap, you have to fill it with 0. So think like this. 3.52, I'm moving 3 places to the right. 1, 2, 3. Leaving a gap, and that gap I have to fill it with 0. So the answer to this is 3,520. So what happens if the exponent is negative? For example, negative 4.2 times 10 to the power, let's say negative 3. So what negative 3 really means is negative 4.2 multiplied by 1 over 10 cubed. But multiplied by 1 over 10 cubed, you can think of it as dividing by 10 or dividing by 1,000. And dividing by 1,000 requires to make this number even smaller, so you have to move this decimal place 3 places to the left. And that makes it negative 0.0042. So you have to fill the 2 places with 0, so that becomes the answer in standard notation. So when you see the exponent as negative, you think of it as dividing. So that's why you move the decimal point to the left. Whereas when you see the exponent to be positive, you think of multiplying by a power of 10. So that's why you move the decimal point to the right. Yet another way that you could help to remember is to remember these two facts. The fact is that if the number is numerically greater than 10, so we're talking about ignoring the negative sign. If you're just looking at the number itself, just the value, if it's more than 10, then the exponent n is positive. If the number is numerically between 0 and 1, then the exponent n is going to be negative. So you can use that to help you remember as well. So take for example, if this was 480,354. So you notice it's a big number, okay? It's a number that's way more than 10, so you would expect the exponent to be positive. So you need to move the decimal point from where you are to where you want to be, which is the first placing right after the non-zero digit. So that requires you to move 1, 2, 3, 4, 5, which means this is 4.80354 multiplied by 10 to the power of. So if you forget whether it's positive or negative, you can think of big numbers. Big numbers means positive. Big numbers, so this is a huge number, so that's why it's positive 5. You can think like that. So for example, if this was 0.325, for example, that's a small number. It's something between 0 and 1. So when you move the decimal point, you know it's one placer because it's small, so you have 10 to the power -1. So you can use the big and small to help you. Okay, so when it's a big number, that's when the exponent is positive. When it's a numerically small number, that's when the exponent is negative. So you can use that as well to help you.